In the previous section, we executed an FPGA VI on either the FPGA target or the development computer by selecting the execution mode for an FPGA target. By the end of this module, you will be able to compile an FPGA VI and describe an overview of the compilation process. Okay, in the previous section, we talked about simulating the FPGA VI on the PC to test it out before you compile. So at this point, we've simulated, we've tested it out, and we know that our FPGA VI is supposed to work. So at this point, we can go ahead and compile it. To do that, make sure you set your FPGA target to execute VI on FPGA target. Okay, so once you've done that, you can hit run on the FPGA VI and it'll go ahead and compile it. Okay, so what happens when you compile an FPGA VI? Okay, now let's describe an overview of what's going on here. So if we start over here on the left, notice that we have LabVIEW. Okay, so in LabVIEW, you have your FPGA VI, and let's say we tell it to compile, and we execute on the FPGA VI and we hit run. Okay, so the first thing that happens is LabVIEW will convert that FPGA VI into intermediate files. Okay, so it's going to generate these files like VHDL and things like that, and it'll send it over to the compile server. So the compile server is going to receive compilation requests from LabVIEW, and then it's going to send these compilation jobs to an available compile worker. Okay, so now we're going from the compile server. It's going to send those intermediate files over to the compile worker. Now that we're at the compile worker, that is going to transform these intermediate files into actual binary data that describes how to configure the FPGA circuit on the FPGA target. So the compile worker is actually using Xilinx tools to do this compilation. So once it's done all that, it's going to take that binary data and it's going to send it over back to the compile server. And then the compile server is going to send that binary data to LabVIEW. So once that binary data is sent back to LabVIEW, what LabVIEW will do is it'll create a bit file, which is a .lvbitx file. And that bit file is going to contain the binary data that describes exactly how to configure that FPGA circuit to implement your logic. The FPGA VI will now also have a reference to that corresponding bit file. And that bit file will get downloaded to the FPGA and will reconfigure that FPGA to execute that logic that you've defined in your FPGA VI. So to run an FPGA VI on the FPGA target, make sure you configure your FPGA target correctly. So make sure you right-click it and then you set it to execute VI on FPGA target. So once you've done that, if you open up your FPGA VI and hit run, now LabVIEW will automatically compile it, download it, and run it on the FPGA VI on the FPGA target. Okay, now let's talk about working with build specifications. To compile an FPGA VI, you'll need a build specification. So if you don't create a build specification, when you hit run on that FPGA VI, it'll automatically create one for you. However, you can also create one manually. If you do this, to create one manually, you can right-click Build Specifications and then go to New and Compilation. And then from there, you can select your top-level FPGA VI. And once you have a build specification, there's a couple things that you can do, which we'll talk about on the next slide. So here are some common actions that you would do once you have a build specification. So let's say we've manually created a build specification. What we can do is we can right-click it and we get a couple different options on there. So one is build. If you select build, then you'll compile the VI. Another option you can select is estimate resource usage. And what this will do is it'll estimate the FPGA resource usage without compiling. So it quickly does an estimation and it'll tell you whether, I guess based on this estimation, it'll tell you whether your FPGA is going to fail or if it's actually going to fit on the FPGA. Okay, so it's kind of a quick way of finding that out without having to go through the whole entire compile process. Another thing you can do is you can generate intermediate files. So if you choose the option to generate intermediate files, one thing that's good about that is it can be useful for catching certain code generation errors. For example, it might catch something like in your FPGA VI, if you're doing something that's not supported, it'll give you an error about that and let you know. Another thing you can do from the build specification is you can display the compilation results. So if you've already built that particular compilation, you can choose this option and you can kind of look at some of the results. So you can see how much space the compilation took up, the speeds and things like that, and get all sorts of specs. Okay, now let's go into LabVIEW and see what the build specification looks like. Okay, let's take a look at the build specifications. So notice in this project, we've got our FPGA target, and we also have a FPGA VI here called Simple Math. Notice that our FPGA target, if you right-click it, we're executing the VI on the FPGA, so it'll actually be targeted and run on the FPGA. If I was to open up Simple Math and hit the Run button, because there is no build specification defined already, it would automatically create one for me. However, in this demo, what I'm going to do is I'm going to manually create a build specification just so we can take a look at some of those options. So if I go to Build Specifications, if I want to manually create one, I would right-click it, go to New, and then Compilation. So once I've selected that, it's going to pop up a window for me. And here I can do a build specification name. So I'm just going to leave it as My Compilation. One thing you want to do is first you want to go to Source Files. And you want to go to your top level FPGA VI. So in this case, my top level FPGA VI is Simple Math. Okay, I'm going to put that over here. And notice that this is set as the default build specification. What that means is if I was to run Simple Math VI, it would compile it using the information that's defined in this build specification that I'm creating right here. Okay, now I'm going to click OK. And notice now that I have a build specification for Simple Math. Okay, so once I have one of these build specifications, if I right click, I do get a couple more options. So like we saw in the slides, if I click Build, this will actually compile that VI. Another thing you can choose is Estimate Resource Usage, and this is a useful way to find out quickly, without compiling, whether or not your FPGA VI will actually fit on the FPGA hardware. Another thing you can do is do Generate Intermediate Files, and what this does is it'll try to generate some of those intermediate files, but in that process it'll tell you if there's some errors in your VI, such as using unsupported objects. And then if you've already done a compilation with this build specifications, you can click Display Compilation Results. And what that'll do is it'll show you the report that's on the compilation, and you can view a lot of different specs such as timing and how many resources it used and things like that. So again, if I had opened Simple Math and there was no build specification already for it and I hit Run, it would have automatically created something and it would have popped up over here.